Hello guys. So as expected, probably not too many year 11s turning up at this time of the day, but that's okay. Okay, so what I would do for the for you guys for the year 11s is that 3 streams that's coming up, and I'll be going through all 3 topics and just 1 topic per stream. And so what I'll do, I'll just choose a random year 11 paper that I haven't done, that I'll just speed run it. Okay, so and I'll just go through the key points of this particular unit. So yeah, so if it's not a lot of people watching, that's totally fine. So that means you get me, you know, if you have any specific questions about the standard, then you can ask me for it. Okay, but let's just get started. Okay, so this is the 2017 Acids and Bases paper. I think I marked this for NCEA not that long ago, 5 years ago. So let's get into it. So with acids and bases, it comes down to again 3 really major sections. The first section is looking at what I tend to call, you know, the atomic structure. You know, so the ion formation, you know, the formula, and you know, why the ratio, why did they form neutral ionic compounds, and all that sort of good stuff. And then the second part, you are looking at the acids and bases reaction, and then the third part is more of looking at the race reaction. Okay, so let's find the first part first. I tend to skip, so this is something that we're looking at today. So let's have a look at this. Okay, acids and bases, to me personally, like, people always ask me, you know, what is the easiest paper to do, and I would always say it's the physics one. Physics is by far the easiest standard to, you know, to pass and to get good grades in. But acids and bases is probably the one that you will be able to, I don't know, study. It's the most predictable exam. Okay, so you spend the hours, you tend to do quite well because the questions tend to be quite repetitive. So let's get started. So we got sodium and potassium both react with oxygen. However, they don't react with each other. So it's saying sodium and potassium don't react with each other. So why do they react with oxygen but not with each other? You answer refer to the electron arrangement of all 3 and the ions involved. Explain how the electron arrangement refer to the position on the periodic table, how the ionic bonds form. Okay, so it's more of a just understanding, you know, if you look at the basics, and this is how I tend to teach my year 11s anyway. So you need to first of all find them on the periodic table. So that's potassium, that's sodium, and that's oxygen. And these numbers are just on the, oops, that's 16. This is 8. So you just find this on the periodic table that you get given, and then you just go through them. So for example, like, and then once you get to here, this is what I tend to do. Like, so for sodium, you're writing with the pen, so PEN. Don't worry about the N. And Adia, I don't know how to pronounce your name. Level 3 stream is tomorrow, bud. Level 3, 3.6, 3.4 structure bonding. Just look at my YouTube channel, the community post. It is happening, you know. So I'm taking everyone having a bit of having a day every 3 days. Okay, so today's year 11. All right, so tomorrow's year 13. So get back to this question. So sodium has 11 protons, 11 electrons. And then this has the electron arrangement of 2, 8, 1. So what this does is that you need to remember that right now it doesn't have a full shell of electrons. So this is going to lose 1 electron to have a full outer shell to become stable, to have an electron arrangement of 2, 8. Okay, so now you have 11 protons, 11 positive protons, 10 negative electrons. So that's why Na becomes Na plus 1. So potassium is the same thing. This is 19, 19. So this is 2, 8, 8, 1. So again, the outer shell is not full, so it's going to lose 1 electron. So it will be 2, 8, 8. So it has 19 protons, 18 electrons. So this is K plus. Whereas oxygen, protons, electrons, this is 8, this is 8, this is 2, 6. So this will gain 2 electrons, will be 2, 8. So it has 8 protons, 10 electrons. So you have two more negatives than positives, so it's O2 minus. Okay, do I do chemical reaction level 1? No, I don't, because that's not the standard that a lot of the school does. So I just covered the majority here. So that's like, say, being a marker for many years, I can tell you that if you just wanting achieved, if you can just do what I did on this particular, the thing I just done, you would have got like 3 or 4 achieved ticks, 2 to 3 achieved ticks, depending on how the question's worded. Okay, so if you need 9, you need 9 to guarantee a pass. 8 will 95% of the time get you a pass, and you're staring at like almost 50% of A points right here on the board, on the screen. So just being able to do the basics will help you to go a long way. All right, so how relates to the position of the periodic table. So what does that mean? So sodium is a group 1 element, so because it has 1 outer shell electron. Potassium is also a group 1 element, it has 1 outer shell electron. Oxygen is a group 16 element, that's why you have 6. Group 16, it has 6 valence electrons. Okay, so why does sodium and potassium react with oxygen? Because sodium needs to sodium needs to lose electron, whereas oxygen needs to gain electron. So what it means that every year the exam question is a little bit different, but you just need to understand in this particular question you got to read the question. Okay, so why does it react with oxygen? Because oxygen need to lose 2, whereas the sodium and the potassium need to gain 1, so you can form ionic bond. Okay, so ionic bonding is when you gain or lose electrons, and then you have got the formation of ionic bonding, and that's how you form an ionic compound. Okay, so why doesn't sodium and potassium react? Why don't they react with each other? Because they both want to gain an electron, and you can't get that electron from anyone else. Okay, so that's pretty straightforward, I hope, in this particular question. But this is something that I would highly recommend every single year level to do, just based on the experience I've had for the past few years with marking level 1 acids and bases. I pretty much marked all the externals so far, like genetics and mechanics and acids and bases, and I can tell you that a lot of students that I know that they know the answer, but if they don't, because in this particular question, because remember this is a few years ago, if you want to look at the recent examination videos, you can find that on my channel, but there's been a trend of where when they ask the questions, they want you to write down the number of protons, number of electrons, etc., etc. So by doing it like this, you actually covered every single number they could possibly ask you to do, and that will normally be a requirement for merit or excellence. And if you really don't know what you're doing for this particular standard, just being able to do what I've just done on the screen right here, you can, like I said, you can almost get half of the points when achieved. And this is like a guaranteed question that always gets asked. Okay, so that's one of the really big thing is the formation of ions. So I'm just using this question to talk about this particular set of questions, formation of ions. Okay, so you need to talk about gaining, losing of electrons. Like say for ions, why do ions form? What is an ion? An ion is when an atom gains or loses an outer shell electron to have a full outer shell to become stable. You put that phrase in, 1 tick straight away, 1 achieved. Just it's not difficult with level 1, and you need to have that in there for merit or higher as well. Okay, let's have a look at the next question. Okay, that's a base question. All right, here's another one. This is the other part of the question that I'd like to talk about. This is again a very typical question, asking you to talk about the ratio of ions. And normally, especially for the recent 3 to 4 years, is that they like to put the question that we just done and this particular question together as one big question. And if you get any one of those right, you will get an excellence. Get one of those right, you get E7. Get both of them right, you get E8. Graph-based questions, yes, Marty, they do tend to show up in the resurrection questions, which we'll get to a bit later. Okay, so for example, for this one, AG20, so you can tell this is AG20, and if you look on the table of ions, you will see that one is AG plus, one is O2 minus. Okay, so this splits into AG plus, this goes into O2 minus, and you may go, how do I know that? You can see those on your periodic table of, on the resource sheet. So why is the ratio 2:1? Because, so you need to look at the question here. So this is where what we do to, from a bit of an inside view from a marker. This point that I'm highlighting right now, that is a merit. These 2 points, each of those, if you can do each of those bullet point, that is a merit. If you can do one of those, it's M5. Okay, not M5, excuse me. You get 1 merit bullet point. If you get 2 merit bullet points, normally there's an M5. You got 5 points for this entire question. So this is a merit. This is a merit. If you can do both, it's excellence. So how do we do the first one? Like number of electrons lost. Okay, so how do we talk about the number of electrons lost? So let's think about this. Ag plus, it has a positive 1 charge. So this means it has lost 1 electron. This O2 minus, that means oxygen has gained 2 electrons. So you can think about like this. Ag want to lose 1, and then oxygen gains 2 electrons. So in order for oxygen to gain the 2 electrons, you need 2 Ags to lose a total of 2 electrons. Because where the heck are the oxygen gonna get the electrons from if you don't have 2 Ags? So that's the first merit bullet point. You just need to understand plus 1 charge means you lost 1 electron. Minus 2 charge means you gained 2 electrons. So in order for this reaction, for this relationship to work, you need this thing to lose a total of 2 electrons, which are then gained by the oxygen, and that's why the ratio is 2:1. Okay, if you can do that, you got a merit. Let's look at the next one. A lot of people tend to get this one. This one's what everyone can do because they will just go, all right, let's look at this. Ag is 1 plus, oxygen's O2 minus. So this is plus 1 charge, this is minus 2 charge. So I need 2 Ag plus charge to give me a total of plus 2, which then cancels out the negative 2 from the O2 minus, because you want to form a neutral ionic compound. And if you can do that section well, then you also get a merit. And if you've done everything correctly that we just gone through, you got an excellence. Well done. Okay, so that's normally, if you go through the past 3 years of exams that I've done on my channel, you will find that it is a trend in that particular regard. So it really pays well if you just spend some hours and learn those bloody model answers or look at those questions. It will benefit you. You can, it's how the tone has been set for the past 3 to 4 years. Same type of questions. You know what's gonna come up in the exam. No excuse that you don't know how to do it. Okay, because especially on my channel, I've done this so many times that you should be able to do those. Okay, so next one we are going to look at some acids and bases. So this is all rates. I can just look at the question. This is all rate. This is technically acids and base. We'll do that a bit later. All right, so this is acid base reaction. Now for I think a lot of people are going to watch a VODs here. So how do you know that a chemical or a substance is an acid or base? The 3 acids that you need to know for NCEA level 1 is given here: HNO3, HCl, H2SO4. So these are the 3 acids that you must remember. Okay, so these are your acids. And for you to, again, I'm only doing this because you're year 11s. For anything that's something carbonate or oxide or hydroxide. So for these things, these are all alkaline or basic or bases. Okay, so something carbonate, something oxide, something hydroxide. Okay, now everything else again, this is not true. Like if you someone, you know, if a senior chemistry student learns CSUS, they probably frowning like, what's he talking about? Yeah, well, I'm just trying to help these guys to remember a simple trend and get them to pass the exam. It's not 100% correct, but it is correct at year 11. Okay, so everything else is neutral. So if you remember this, then this particular question shouldn't be too hard, because when we look at this, you can see the HNO3 right here. So this is the acid, and then you can see this thing here. So this is something carbonate, you know, so sodium hydrogen carbonate. This is a base. Can you see this is NaCl? Can you see it doesn't fit into anyone? Don't look at the Cl and go, oh, it's HCl. You know, they're not the same thing. HCl is hydrochloric acid. NaCl is this everything else, which is neutral. Okay, so just remember that. If you can do this part, that's gonna save you a lot of points in the next few steps. Okay. Early on level 2 stream we had one yesterday, so you can see that on the VODs on my channel. That was for structure and bonding. Organic is on Thursday. Reactivity is on Sunday. Saturday, Friday, Saturday, not lies, Sunday. Okay, yeah, you were here yesterday. Organic is Thursday. Reactivity is Sunday. It's on the thing. It's on the YouTube community chat. Just read that post. Okay. All right, back to where we were. So we know this is an acid, and then you can see here red litmus paper. Acid always, acid only turns litmus paper. Will only turn litmus paper blue. So this is neutral. Neutral will always, you know, it doesn't change the litmus paper color. This is a base. When you put base with red litmus paper, this will turn blue. Okay, so that's how you know straight away that NaHCO3 is different, because the base will always turn the litmus paper blue. And this is how I tell people to remember: B for base. Okay, so blue for base. Okay, so B for B, blue for base. So if your base, if you have a base, you put it in red litmus paper, you go blue. If you have a red litmus paper, if you have an acid, if you put it in a blue litmus paper, it will go red. Just remember that. Okay, now next one. So this is carbonate. So this is carbonate. Remember, again, this is a base. Okay, so you should know that when you have acid plus carbonate, this is one of those acid-base reaction. Acid plus carbonate give you salt, water, and carbon dioxide. And this is the thing that we're interested in, because if you, how do you know that? Because remember, this is a distinguishing test. So if you have an acid that react with a carbonate, you are going to see bubbles. Or you know, don't say formation of gas. You know, how can you see formation of gas? You can only see bubbles. All right. So, and then this one, NaCl is neutral. It doesn't do anything, so no reaction. And then NaHCO3, this is a base. This is a base. Base doesn't react with base, so this is no reaction as well. So this is how you can use these two different things to distinguish what you actually have in this particular structure. Okay. All right. Someone just messaged me on Discord. That's okay. So let's look at the question. So we complete the table, explain how the thing allows you to identify your solution and write a balance equation for any reactions. Okay. So if we put this in writing, you can just remember acids, you know, plus carbonate. So in this particular case, actually, let me just reword it in the way that we figured it out. So at the beginning, how do we know it turns blue? Because NaHCO3 is a base, and base turns, I mean, you can have a look at the answers, it turns red litmus blue. Okay, and then you can look at the other one. HNO3 is acidic, and then NaCl is neutral, and therefore there's no color change. Okay, so that means they both stay red, no change. Okay, so that's how we know that HCO3 is one of those solutions because it turns the color blue. Now for the next one, no, it's not our school exam paper. This is a 2017 NCEA paper, but 2017. So how do we know to test for the other one? So what solution we have? HCl, HNO3. So if I have HNO3 reacting with NaHCO3, if react with K2CO3, you know, how do we know we make bubbles? And I'm gonna say it one more time. This is the last time I'm gonna say it this year because I'm not gonna do acids and bases anymore this year. If you are sitting and listening to this, and if you're someone that just want to pass this exam, you just want the 4 credits, take it and run away and never do chemistry again for the rest of your life, don't spend much time on the balancing or doing the equation part. It is not worth it. With the amount of time that you spend on, like, you know, you need to remember acid plus salt plus carbonate give you salt, give you water, give you carbon dioxide. Like, I've seen many of my students that, you know, that's sort of on the verge of passing, not passing, and then I always recommended them to just let it go, you know, not best use of your time. Because with that time you can spend it on other things like pH colors and ions formations and all that sort of stuff. You will get much better return. Like, say, you know, the question that we did over here, like, look at this, look at that screen, that is 4 points. That's 3 to 4 achieved ticks, and if you can do that, you're almost there to passing 4 credits. Okay, so that's worth it. Like, that wouldn't take you long to remember or try to understand how to do it. But for this, you need to actually memorize the formula and actually know how to do it. And if you got it wrong, you miss out on 1 tick, 1 point. Not worth it. However, if you're sitting here and you're merit or excellence kid, then this is a question that you definitely should do, because this has the least amount of writing and there's only 1 correct answer, and it is something that is absolute crucial if you want to do level 2 chemistry next year. If you can't write a balanced equation in year 11, honestly, there's no point doing level 2 chem, like, because it's one of those it's so fundamental, because when you get to level 2 chemistry, the jump is huge. Okay, but enough of that. But I'll go through this anyway. So you got nitric acid, potassium carbonate. So what do we make? We make salt, so that will be KNO3, potassium nitrate, which is a salt, and then you make water and you make CO2. So this is what I meant. If you don't get why I make those products, it's probably a little bit too late to do that now. By the time you're watching this, spend that time elsewhere where you can easily, you know, get more points elsewhere with the amount of time that you're wasting remembering this equation. Okay, so balancing, so if you can do that, you're gonna merit. If you can do this, you would get, let me just make sure I balance this right. Yeah, if you can do that, then you got an excellence with the red part. Okay, so that's how we know that that's how we can differentiate this nitric acid from the rest, because it will make bubbles, which is right here. Okay, so the NaCl is a thing that doesn't do anything. All right, so that's one part of acids and bases. Anything else? So here's another one. So silver oxide is a base with hydrochloric acid, so you need to write a word equation. So do the word equation. So silver oxide, they will give you like 2 to 3 questions like this throughout the paper. So it's about 2 to 3 achieved ticks. If you can't do one, you can't do the other. It's as simple as that. So you make silver chloride. So it's always, if you want to have a go, it's always a metal bit combining with the leftover of the hydrochloric acid, which is chloride, plus water. I don't know. So this is your acid plus base. Okay, so acid plus base give you salt plus water. Silver oxide is Ag2O plus hydrochloric acid is HCl. And you may go, how do you know Ag2O? Well, silver is Ag1 plus, O is 2 minus, so you need 2 Ag plus to balance 1 O2. That's why it's Ag2O. Okay, so silver chloride is AgCl plus water is H2O. And then if you can do that, you got an you got a merit. And if you can balance it like I'm doing right now, then you have got an excellence for this question. Okay, So again, balancing equations, more of a, if you got it, you got it. If you don't get it, don't waste time on it. Okay. Anything else? Oh, this is a very, very typical question. Okay, so this is where, you know, if you're sitting on the verge of achieve/merit, this is where something that you can do to cement your grade. Okay, so we have a solution of sodium hydroxide slowly added to a beaker of hydrochloric acid. Okay, so you're starting out red. They want you to relate the changes to the approximate pH of the solution, link the pH to the ions, and then explain the neutralization. So what you could do, so this is one of those points I was talking about before. You can spend like half an hour remembering this, and then you will get better more points out of this. Okay, so for example, this is what I always do. Like, it's just, I think for the past few years they stopped asking this question every year, but they just still do it every now and then, because they probably, you know, with teachers like me that's telling the students how to do it, and it's kind of defeating the purpose a little bit. But you just need to remember 1 to 14, this is your pH scale. So this is your pH scale, and the one is at 7, this is neutral. Okay, this is neutral, and then from 1 to 6ish, this is acidic. And then from 8 to 14ish, this is a base. And then you need to remember the colors. So 1 to 2 is red, 3 to 4 is orange, 5 to 6 is yellow. I always say 8 to 10, 8 to 11 is blue, then 12 to 14 is purple. Now, if you say 8 to 10 is blue and 11 to 14 is purple, no one's gonna mark it wrong. It's kind of insignificant. So those are the universal indicate colors. So red, orange, yellow, green. Sorry, I forgot green. Green, blue, purple. You know, the colors. And then you can remember this side is your strong acid. Okay, and this side is your strong base. So it's always the end of the spectrum that's the strongest. And then to do the ions, so you just need to remember 1 to 2, you have lots of H plus ions. You know, that's what acids have, lots of H plus ions. When 3 to 4, you have a little bit more. Then 5 to 6 is that you still have H plus ions, but not as much. And then 1 to 7 is when you have H plus equal to OH minus. Then 8 to 9, you know, you can say 8 to 11, you have more OH minus than H plus. Then 14, you know, to 12 to 14 is that you have a lot more OH minus compared to H plus. If you can do that, guys, like I say, if you're on the verge of passing, you are again staring at 3 to 4 achieve ticks if they ask you this particular question. Because if you look at those bullet points, what they're asking you to do, relate the changes of colors to the pH, which is right here. Here's the colors, boom, here's the pH. I've done that. Link the pH to the concentration of ions. That's the pH, that's the ions, boom, done that. And then for the neutralization part, you just need to, this is neutral, you just need to understand, you know, at pH 7, you know, the solution is neutral. Why is that? Because you have got equal concentration of these, and you also have neutral salt and water. Because what is neutralization? Neutralization is when you have the acid and base balancing each other out, and then you produce salt and water. Okay, so you can, you know, that's, I don't want to rewrite all of the questions. I don't want to type it all out, especially if you're someone from my class, I would have done this for you in class. But this is like, if you get a question like that, you just got to watch out for some of the trick question they do. I think for our school exam, they started with like a pH 4. And they started, okay, so I started with pH 4, what colors would it go through? So you start with orange, go to yellow, go to green, go to blue, go to purple. You know, you don't go to red because you're starting at orange, for example. You just got to apply yourself a little bit. But if you just, you know, someone that just want to pass, go into the exam, boom, if you see this type of question, you know, this type of question, just don't even doubt yourself. Chuck this thing on there. That will take you 5 minutes to write. And more, the chances are that you got a couple points, at least 2 to 3 achieve ticks out of that is pretty damn high, even without looking at the question. Okay, so and by doing that, that can actually get you started to, you know, write more for the you know, explain this what you just wrote, put that in writing, and you might be getting more than you expected at the beginning, to be honest, because you might be surprised, because NCEA, especially with NCEA, so what they're trying to do is that, I've said this numerous times, they're trying to get more people to pass, because it's not looking so good statistically, so they're trying to make it easier with the marking, trying to get you guys to pass. Okay, so if you get a question like that, boom, that's your way to go. Okay, so that's I think there was another balancing equation one here. So there's another balancing equation one. So sodium carb. So I'm just gonna skip this. This is boring. I'm just gonna go here. So NaHCO3. And in the exam, if you're someone that wants to get merit and excellence, you don't need to do the word equation. Okay, so if you're someone doing merit and excellence, you can just bypass this. Just come straight to here. This is strictly only achieved, and this is merit / excellence. Okay. So sodium carbonate plus sulfuric acid, you will make sodium sulfate, Na2SO4, plus water, plus carbon dioxide. And this is, if you can do that, you got merit. Now there are 2 NAs here, so there's 2 Na. Once I've done that, I got 2 H's, 4 H's, I need to put a 2 here. And if you can just do what I did in the red part, then you have got the excellence, okay? So there's another one. Are there any more that I need to do for the acids and bases part? I think that's pretty much it. I'm just going a quick browse. I've done this, done this, done this. I think that's the end of the question. Done that. Oh, and by the way, if the exam asks you what type of reaction is it, they're giving you a free point right there. And if you ever forgotten what type of reaction, guys, this topic is on acids and bases. Write that down, or if you can write the word neutralization, even better. Free achieve tick right there. Okay, now the last bit is on rates of reaction. So the rates of reaction is the only thing I can tell you that right now. If you do, my year 12 chemistry students will back me up here. Rates of reaction is the only thing that gets continued in year 12. So it definitely pays dividend to study that well now, because you're going to see that again next year, and the questions are so damn similar next year. So let's have a look. So you got 3 factors. You got concentration, surface area, and temperature. Temperature is the hardest one, and that tends to be the one that always gets asked in the end of your examination. So this question is asking about temperature. So the first question, what causes fizzing? CO2 gas. It's carbonate plus sulfuric acid. Acid plus carbonate is carbon dioxide gas. So they're asking you, why was the fizzing the fastest immediately at the thing, and then you should refer to the rate of particle collision. So again, this is essentially just asking you to explain this graph. So why is it the fastest over here compared to somewhere over here, for example? So you just need to be able to explain that at the beginning of the reaction, you have the highest amount of reactant particles, in this case HCl and then the other carbonate thingy-majiggy, sorry, H2SO4. So at the beginning of the reaction, you have the highest amount of particles of H2SO4 and NaHCO3. That means they'll, you have tons of those. They're more likely to collide and bump into each other and then react and then produce a product. Okay, so as time goes by, you will end up with less and less of these reactant particles, and then you produce less and less of the gas, and then you will see a graph like this. Now, if I were to redraw the graph to fit this, since Marty asked about graphing, because I know he's, I know you asked me a few questions about this already. So this is mass of the container. Sometimes to change it up a little bit, they do it like this. You know how in this particular case with the thing's fizzing, so it's fizzing, is losing gas, so that's why the mass of the container will decrease over time, because you're losing content, you're losing the carbon dioxide. So again, so you can see at the beginning you're losing a lot more CO2 gas as you are comparing to the middle part of this of the graph, because same reason, you have lots of chemicals at the beginning, they bump into each other, collide, blah blah blah, frequent. higher number of successful collision per unit time, and therefore you produce more products over time, and therefore you lose some, and the mass increases more at the beginning. Okay, so this graph and this graph is essentially the same thing, but you just need to look at the scale. This is the axis, it's mass of containers, so you decreases over time, whereas over here this is the product. This is how much of this is being produced. Okay, well, mass is just mass. Okay, so the rates reaction is here. So what is the effect of increasing temperature? So you just need to remember this. Temperature is the most difficult one, and again, if the rates reaction part is so free, if you just spend 2 hours on 3 years of past exam papers, then you have a really good idea what you're going to do for this. Okay, so increasing temperature. So if we increase temperature, you're doing two, essentially just one thing. You're giving it more energy, So there's more EK. So the particles are running around with more EK. So that means they are going to collide more often. So if they collide more often because they run around more, that means you have higher frequency of collisions. Higher frequency of collisions because they collide more often. And then the next thing that we're going to talk about is that because there's more, because they're colliding with more energy, then a higher proportion of these collisions, higher proportion of these collisions, a higher proportion of these collisions will collide with sufficient amount of energy, due to greater EK, because they're colliding. Excuse me, I'm just trying to write as quickly as I can. So what it means is that the particles, they're colliding more, and then because they're colliding more, a higher percentage of these collisions will have sufficient amount of energy to start the reaction. Therefore, you have a higher frequency. You have a higher frequency of successful collision. Now, I've seen people doing this before. If you just, you're probably seeing someone, for me doing it before, you've probably seen me saying per unit time. If you say per unit time, then don't say frequency. Per unit time and frequency are like the same thing. So if you say, let's say for example, you look at this answer here, if you say there's a higher frequency of successful collision per unit time, we can actually mark you wrong, because you are telling, it just shows you don't understand what frequency means. Frequency is the equivalent of per unit time. It's how often something's done. Okay, so you don't say per unit time. You just don't say that twice, because that's stupid. It just means you don't know your vocabulary. So you either say higher frequency of successful collision, or you say higher number of successful collision per unit time. Okay, but if you want the merit or excellence, you have to say that. Okay, you have to say that. I can't stress it enough. If you don't understand rates reaction, I strongly recommend you to have a look at those model answers on the NCEA websites with the answers. Grind through those, and you shall be rewarded. Okay. Anything else that I need to do? I think that's this paper. Thank you, Josno. No, it's okay. We'll do level 2 on Thursday. But that's this paper. So this paper was quite short, and they're getting shorter and shorter. So yeah, if that acids and bases, I've done this so many times on my channel. I think it's one of those really fair standard. If you got some time, put in some time and effort, you can do well. So for the level 1 people, if you have any questions, you want to chuck it down in the chat, and I can answer them. So it's almost like having a free one-on-one tuition with me. Good on you. But if not, I will probably just hop off hop off, and because this is more, it's the same questions, just I get kind of tired of talking about the same thing, but I think it will benefit you if I just go through that again. Oh yeah, level 2 maths is tomorrow, so that's why I'm not doing maths today. Sorry, not doing chem today, because I don't want to clash with Mr. Infinity plus one stream, because I'm pretty sure he will do something for you guys. Yeah, I think timetable wise we definitely have it pretty easy for chemistry. Yep. Right, so any year 11s that have any questions on S's and bases? Yeah, no problem, Gracie. It's more of a, honestly, I personally get incredibly frustrated with students, especially students in my class, that don't do well in level 1 science. Again, it's not personal. I like all of them, but it's more of a, if I told you that what the questions are before you go into any subject exam, if you know what the questions are going to be and you still can't do well, then it's and I'm going out of my way to sort of help you to get there, then it can be a little bit frustrating, as you can see from you can imagine from my end. But yeah, very S's and bases, very, very standard, so I don't expect too many questions, so that's good. So we'll call that a night then. What do you consider, here's a question, what do you consider S's and bases hardest question? What do you consider S's and bases hardest question? For me, I know for a fact that a lot of people find the balancing equation questions the hardest. And for some, those are just freeze. Okay, but I think it's either that or the rates reaction questions, because the rates reaction questions, you have to hit the right vocabulary, you have to cover everything. I mean, all of them is, you can grind through the exam papers, so none of them should be too difficult. And then what papers should you do, that's up to you, mate. Okay, so if you want some exam strategies, this is what I would recommend. All right, so think about the human psychology side of things. Imagine if you got 3 papers, I would always do the one that I'm the most confident with. The reason for that is that if you build up a bit of confidence by doing the paper that you feel that you're best at, you should be able to carry that confidence to your other papers. So even though you might not be so confident, but if you made a really good start, then you should at least have a bit of momentum and do probably a little bit better for the other 2 standards that you may not have done as well if you started those. Because if you started the worst paper, you just look at the question and you're like, what the heck am I doing here? And then that just deflates you, and that will just demotivate you. So that's my personal opinion. And Gracie, are the excellence criteria the same every year? Yes, and I can tell you that for this 1 year when we marked for NCEA, we literally used the same marking schedule for one of the questions, because the question was exactly the same, except the formula, the chemical that was used. Okay, so it's literally the same questions. What if I finish all the exam papers for chem? Do I redo them? If you finished, and I've said this numerous times for people that do internals, is that I wouldn't redo them, Marty. I would just cover up the answers and just go through the answers in my head. Like, don't look at the questions, cover them up, and then just quickly and just have a go through in your head. If you write balancing equation, write it down again, because it doesn't take a lot of space. But just run it in your head again and just compare to what you wrote, like say half an hour ago. If they match, then don't change anything. That will be the most efficient. When doing equations, do we include the states? Not required in level 1. It's not even required in level 2. It's not, well, it's kind of required for level 3 for a particular standard, yeah. But when doing equations, you do not need to include the states. Not required. Okay. Okay, not required. I'm pretty sure even if you put them in, if they're wrong, we kind of just ignore them, because that's not a year 11 thing to do. Okie dokie. Any more questions before I call that the night? So this is essence and basis. So on the, what's today? Today's Tuesday. So on the Friday, we will do mechanics, and then on the Saturday, Sunday, on the Monday, we will do genetics. Okay. So I'm not coming back to essence and basis anymore. So if you have friends that do science, and they can just rewatch the VODs, and I got tons of content on my channel, so there should be plenty of practice to do. Alright, so sweet. I think everyone's pretty happy. If you're happy, then I'm happy. Then sweet. I won't hold you guys here for too long. Then I wish you have a do I expect this year's paper to be easier? I don't know, man. That really comes down. I can tell you that the general trend, it gets progressively easier and easier every year. because the quality of the work that we see in front of us every year gets worse and worse every year. So what do they do to lower the standard, to make the questions easier? Yeah, but that's another story. Okie dokie. All right, thank you guys, thank you for turning up. So if you want to turn up to mechanics or genetics, feel free to pop into the channel around this time. That's on the community page. And yeah, I'll see you guys around. Have a good night. Good luck with all the exams. Cheers.